Hello everyone, the problem that we're looking at today is the 2019 February Silver Problem 3 of Revegetation. And obviously I am once again recording my hand gestures so I can practice my speech tournament, which is next Thursday. First of all, the problem is quite lengthy, so you can pause the video for a second and then read it for yourself. Okay, so basically, I'm going to simplify this into complete mathematical language, but each cow basically acts as an edge that connects two grass fields, and it is also a restriction. It restricts whether the two grass fields has to have the same type of grass or different types of grass. Now, Farmer John has exactly two types of grass that he can plant in each grass field, and he has to plant some type in each of the grass fields. And now you're trying to determine the number of ways in which Farmer John can do so legally, satisfying all his cow's restrictions. Okay, so literally my explanation already simplified this problem a whole lot for you because I already told you that this is going to be graph theory. And that's kind of the first breakthrough. If we can consider cows as edges, this whole thing become a lot easier. So if we know that our edges, we also know that we're trying to find a number of ways in which we can plant the grass, it is quite obvious that we want to consider each connected component separately because each connected component, the ways that we do the grass in each connected component would not affect other connected components at all because there's no cows or edges connecting those. And also notice that for each connected component, you can swap around the order, the type of grass planted in every single field, and you'll still have a legal plant, obviously, because you only have two type, and if you swap everything, it'll still be legal. So now we just have to consider the number of ways for a singular grass field. How do we find whether it is legal? Because we know as long as it is legal, for a single connecting component, as long as it is legal, the final answer is just 2 to the number of connected components power. So this is actually still quite easy, and we just use the simple trick of DFS, depth first search. So obviously, here we have a vector, and the first element is the destination point, and the second element is the type of edge. If the type is 1, that means they have to be the same. If the type is 2, they have to be different. And for DFS, we just DFS like regular. If it's visited, we don't go to it again, obviously. Num is the number of connected components, and since we are asked to print the answer in binary, because obviously the answer will be really large if it's in decimals, because it'll be to the same level of 2 to the 10 to the 5th power, which is enormously large. So if we print them in binary, it's just you print a 1, and then you print a bunch of zeros, and the number of zeros is just number of connected components. So now let's just go to the DFS function. So for the DFS, each connected component is treated separately. So they each have a new DFS. We have to clear out all the arrays, but there's not really in this program specifically. B is the destination point. C is the type of edge. And then tag is the type of grass that we need to plant on this destination point B if it were new. Just using the restrictions and the type of grass that we planted on the current field. So, okay, let me see. Where does the current field's grass type? Oh, yeah. Okay. So it's just same or different. So V in this case is not necessarily just the visit array anymore. It usually is just marks whether a point is visited. However, this time it means it can be 3 values. 0 means it's not visited. 1 or 2 means the type of grass that's planted on this. So Vx is the type of grass that we planted on point X, and using this very fancy binary operation, we can find the type of grass that we have to plant on B, the destination point, using this relationship of C. And using this tag, if we know B is visited, so if B is not 0, and B is not equal to tag, that means this whole input does not work. This whole test case is just a 0 because one contradiction has occurred, and one contradiction is all we need to make this whole test case not work. So we update check to 0, and if check is 0, we return the whole thing. And obviously, if it's not, if we've already visited this and we didn't break up here, that means that VB is already tagged. So we just don't keep going. Otherwise, we're going into an infinite loop. Otherwise, if we haven't visited this, we give VB the value it needs, and then we DFS into B, and then we continue the process. So hopefully after this code and the explanation filled with hand gestures, you will understand how to solve the 2019 February contest gold silver problem 3 of not gold silver. USACO 2019 February contest silver problem 3 of great vegetation. Okay, thank you for watching and I'll see you tomorrow. Okay, very great. Today I did not grind. All I did was after school I just went to the youth orchestra rehearsal that I go to every single Tuesday and came back home, realized I had to buy supply from a competitive programming club at the school, and obviously I had no time for anything left. However, I did do one problem, and that is a bronze problem, I believe, that I'm doing just for the club. And I need to explain to the stupid people what two-dimensional loop or something is. I had to write a Python. I had to write a Python code, freaking Python code for this problem. Like, who even cares about Python these days, except for people who are just starting coding and does not know any C++ at all. Anyway, but like that's what we're doing. And I mean, I did make the decision, but it's not the best. And we had to make that decision of doing Python. But after all, there is no way anyone just starting coding completely new is going to learn C++ on the first few meetings. So Python was our only option. So I had to write this whole problem in Python. And then it actually took me like 10, 15 minutes even, which is absolutely embarrassing. But yeah, it's also Python. So that's slightly of an excuse, but it's also just because I'm so freaking rusty. Yeah, and also my hand gestures are falling off. I'm looking at my notebook literally right now to see what hand gesture I should do. Like this, yeah, that looks like I don't know what I'm doing. So yeah, that is the grind for today, which is basically nothing. But I did do one problem, and I did record it down on the doc. So yeah, and my logo streak already stopped, so I don't really care about that anymore.